This is number 12 from the review problems, and this is an Atwood machine. A device known as Atwood's machine consists of two masses hanging from the ends of a vertical rope that passes over a pulley. Assume the rope and pulley are massless and there is no friction in the pulley. The two masses are 3 kilograms and 4 kilograms. Draw a free body diagram of M1 and M2. Be sure to clearly label your coordinate axes. Apply Newton's second law to M1 and M2. And then solve for the magnitude of the acceleration, and then calculate the magnitude of the acceleration and the tension in the rope. So our givens and finds are, let's see, M1 is equal to 3 kilograms, M2 is equal to 4 kilograms. Okay, and now we're trying to find the acceleration. So we'll draw a picture. And we'll say that here up is the positive y, and here down is the positive y. So we're assuming that our masses, this one moves up and this one moves down. And that makes sense because I have 3 kilograms on the left and 4 kilograms on the right. And so for our free body diagrams, for M1, so this is A. So M1, we have the force of tension and the force of gravity, and it's moving up, so I'm going to make the force of gravity smaller than the force of tension. And then for M2, I have the same thing. So here the force of gravity is going to be bigger than my force of tension. And I've already labeled my coordinate system to show that I'm saying that up on the left for M1 is positive and down on the right for M2 is positive. So now I'm going to part B, and I'm going to apply Newton's second law. So I'm going to start with M1. So F is the sum of the forces is equal to M1A. And now the sum of the forces, the components, are right from my free body diagram, and up is positive. So my tension is positive, minus Fg is equal to M1A, and T minus M1G is equal to M1A. So T is equal to M1A plus M1G. Just brought M1G over to the other side. And now I'm going to do the same thing for the second mass. Sum of the forces is equal to M2A. And now remember that my down is in the positive direction for M2. So I'm going to start with Fg because that's down and that's my positive now. So Fg minus tension is equal to M2A. And so here, my acceleration is also down, right? This is moving this way, and this is moving this way, and it's speeding up. And so my acceleration here is down, and that's positive, and my A's match. So I'm going to solve for tension, and so I'm going to add tension to both sides. And then I'm going to solve for tension by subtracting M2A. And I'm also going to plug in for Fg. So Fg is just M2G. That's that. And then I'm subtracting M2A. And now what I'm going to do, I'm going to set these two tensions equal to each other. And now I want to get the A's together, so I'm going to add M2A to both sides. And I'm going to continue with M1G equals M2G. And I'm going to bring this over. So I'm going to have M1A plus M2A is equal to M2G minus M1G. And now I'm going to factor out my A. So I'm going to have A, M1 plus M2 is equal to, I'm going to factor out my G, M2 minus M1. And so my A is just divide both sides by M1 plus M2 is equal to G, M2 minus M1 all over M1 plus M2. And so that's what they ask for in the problem. They want, without plugging any numbers, solve for the magnitude of the acceleration. So this is my magnitude of the acceleration. And then in part C, I need to solve for the values for the acceleration and the tension. So I'm just going to plug numbers in for the acceleration. So acceleration is equal to 9.8 meters per second squared times m2 minus m1, so that's 4 kilograms minus 3 kilograms, all over the sum of the both of them, so that's 4 kilograms plus 3 kilograms. And so I get A is equal to 1.4 meters per second squared. Okay, and so to solve for tension, if I look here, I'm going to pick one of these two. So I'll pick this one right here, M1A plus M1G. So tension is equal to M1A plus M1G. Double check. M1A plus M1G. So T is equal to 3 kilograms times 1.4 meters per second squared plus 3 kilograms. So let's fix this, and I'm just going to say M1A plus G. So this is 3 kilograms, and then A is 1.4 meters per second squared plus 9.8 meters per second squared. So my tension is equal to 33.6 newtons.